Hello, everyone. So we continue our TypeScript journey. The last class we talked about introduction, and also we also mentioned some types in TypeScript. So today let's take a look at functions and type inference. So how do we write functions in TypeScript? They're actually different, the way we write it in JavaScript and the way we write it in TypeScript. So, and then how do we also make use of the type inference that TypeScript also gave us in functions? So now the core idea is that this class is about learning how TypeScript handles functions inputs. All right, these are the parameters. Okay, how you also handles functions output. So you know that functions can take inputs, that's parameters, and it can also return some values, that's the return value. So every value, whether the input or whether the parameter has a type, the output, whatever the function is also returning, also has a type. Okay, so it's all we're also going to be looking at how TypeScript handles automatic type detection. That's inference. All right. Then we'll take a look at safe function design. How do we design our functions so that it will be type safe? Okay. Now the big picture is that in real systems like the fintech, APIs, applications, data flows through functions like pipelines. Do you understand? Data flows, most of the things we do. Yes, even if we're using object-oriented programming, the methods are still the things that still drive whatever we are doing. So a user's input goes into a function will validate and then do processing and then respond. All right. So whenever, let's say we write an API, our backend, our front end, whatever it is, a user um, gives us an input. The input goes to the function. The function will do some validation. Okay, checking the type, checking if the input is actually valid, then does some processing and give us response. Then TypeScript ensures that every step is safe. Now you might not understand whenever we are preaching use TypeScript, you might not really understand it. But if you have written a big application in JavaScript, you would understand the pains, especially errors that come at runtime. So that is why we are preaching TypeScript. So let's take a look at function types in TypeScript. The basic function typing, we look at this function add. You can see that in this case, the parameter A has a type. The type is number. The parameter B has a type. The type is number. And it is also returning a number. So let me take you to Visual Studio Code. Okay. Um, okay, let me just take everything out here. So let's say we have a function, the function is add, and it takes a parameter. It takes two parameters, A and B, all right? And then it returns, let me write it in the normal JavaScript, it returns A plus B. Okay, but if you look at this, TypeScript is warning us. It says A implicit has any, so let's give it a type. So I'm going to give it number, and you understand how we give the type, colon, then the data type. Now, in as much as TypeScript would also infer the return type, we can also specify the return type by putting after the bracket, we put colon and then return and then the data type we are returning. So in this case, we are doing A plus 1 B, which is addition. So addition will return a number. Do you understand? So as we go on, I'm going to explain reasons why this is actually important. So you can see now that if I try to call this function, all right, and then give something like a string, it will flag it as an error. Look at it. It says that string is not assignable to a parameter of type number. Do you understand? This is the reason why TypeScript is very, very important. So normally in JavaScript, this would go, all right, but you will not have this error. Imagine now we are now saying A plus B. So if this was JavaScript, this is going to give us concatenation and it's not going to give us the result that we expected. So that is the reason why TypeScript is very, very important. Okay. So the breakdown here is that A is a number. That's the input type, the type of the input. One of the inputs, the parameters A, the data type is number. So we are specifying it so that TypeScript compiler will help us dictate some errors during development. B is also an input type. Then the return type is also a number. And let me show you why this is important. Because I have specified that this function is returning a number. So this is the signature. This is the signature of this function. If I go on to return something like a string, look at what will happen. You can see, if I take my mouse over this squiggly red line, you can see it will say string is not assignable to type number. It is expecting that we return a number and we are returning a string. But if I go on now to return a number, that error goes away. Okay, so this is the reason why TypeScript is very, very important. If you have not gotten the book to read to understand TypeScript, chat me up on WhatsApp, come to the community, come to WhatsApp group, let's talk. All right, talk to me, DM me, however, whichever platform or application we are using, okay, at the time of this video, all right, so that I can send you the book. So why return type matters? I have just shown you one, all right. If I mistakenly return a different data type that is not the return type, that will be a problem. You just saw it now. So in this case, we are returning a string. We are returning a string, and of course, it makes sense there because we're also returning a string. But if you try to return a number here, there will be an error. Okay, try it out. I just showed you, so you can also try it out. It ensures consistency in the output. All right, but this is no return control. In this case, now look at it. We don't have any return type, so this is going to return anything. And it means that, okay, let me show you. So look at it. There are a couple of things that can go wrong. If I try, in this case now I'm returning a number, I've shown you that if I try to return a string, all right, there will be an error. Okay, so that is one benefit of the return type. Secondly, if I now say const, okay, let's say I have a string, maybe I call it game, whatever it is, and then I give it a type of string, or I do the inference. But now, if I try to now say game is equal to add, look at it, it will not work. There will be an error here because TypeScript knows that we are returning a number, and TypeScript says this is returning a number, and you're trying to assign a number to a string. It will not work. These are common mistakes we make when we write our code, and these mistakes you will see them at runtime, which is very dangerous. But TypeScript is actually helping us now. It says you can't do this. You say you can't do this, so it has to be, this variable has to be a number data type. But in this case, it's a string. But if I go on to change it to number, or maybe I assign it to a number, then there will be no problem. So everything is working fine. All right. So you need to your inputs, your parameters have to be typed. Your return types also have to be typed too. So type inference, TypeScript automatically detect the types. Variable inference, in this case, now TypeScript knows that this variable is a string data type because of the assignment. We are assigning a string value. TypeScript will infer it to be string. So whenever a function, in this case now, we are not returning, we did not specify the return type. But TypeScript is going to infer that it is a number because look at it. The inputs are numbers, and there is a multiplication between the two inputs. So TypeScript is going to infer that it is a number. Let me show you. If I remove this number data type, that's in that return data type, you can see nothing happens. So even if I take this thing, it infers, look at it. It does the inference for us. This is not the signature I have in the declaration, but it has inferred it for us. If I take my mouse over this add method, it has inferred that it's number, but we didn't have it there. So this is inference in play. So TypeScript looks at the assigned value, the return expression, the assigned values, the return expressions, the function behavior. This is where it gets its data to infer. So why inference is powerful is that you don't need to overtype. So inference helps us not to type too much. All right. We write less code. We don't type too much code. So in this case now, the return type here is a string because we are doing some concat. First of all, the assigned value, the return expression in this case now is returning a string, and in this case we are doing concatenation. So that is why it will infer that it's a string data type that it will return. Okay. Function parameters, the types, okay, of course, our parameters, the types of the parameters. A function can take multiple parameters, you know that. So, but we have to type them. We have to make them type safe. So in this case, um, this is a login function. So after we perform all the processing we have to perform, we'll return true or false, whether it is successful or it's not successful. All right. Then we also have optional parameters. How do you make a parameter optional? You look at the question mark. The question mark should come after the input name. So in this case, if I want to make if I want to make B optional, what I'm going to do is I'm going to do this. I'm going to do this. So, but for me to, I'm going to rewrite this code so that it will accommodate uh, the optional. So in this case now, even if I don't provide the B, so if I come here now, I don't provide B, there will be no errors. Look at it. It's optional, so I must not provide it. But if it is not optional, I must provide it. The add method is already crying. It says argument. It expected two arguments, but got one. But the moment I make that be optional, there will be no error because it's not expecting it. It's not expecting it, but it's just that I have to now add something in the code so that if B is available, it will take B. If it's not available, it will take 0. All right? All right, so that question mark between the variable name or the input name and the colon. All right, that makes it optional. So it means that age may or may not exist. Okay. Default parameters. Now, you can give your parameters default values. So I can go back, instead of making this parameter optional, I can go back and give it an optional value. All I have to do is to come and say equal to 0. So you can see, in case I do not provide in case I do not provide it, it will take, okay, look at it. Okay, so in case I do not provide, B, all right, the value will be 0. But if I provide B, it will take the value. Do you understand? In this case, we said that we give B a default value. So in the case that we do not have B provided here, we can actually, TypeScript will take it to be 0. But whenever we provide B, in this case, we are provided 9, the value will be 9. So optional versus default. Okay. With the question mark, it means that the value may be missing. All right. But when you have an optional input or optional parameter in your function, write your code in order to accommodate that in case it is missing. So the fallback, the equal to, like the default parameter, the equal to, in this, the one we have here, is a fallback value. In case we do not provide it, this is the fallback value. Okay. So, but if you take a look, this is more of optional. Even the default value is more of optional. If I take my mouse over, you can see now that, look at the signature. It's optional. But in this case, I do not have, in short, basically, instead of me to even say optional value, in this case, instead of me to even do this, I could just, depending on the logic of my program, depending on the business rule, all right? But you can see that even if you make the parameter default parameter, all right, TypeScript is saying it as an optional parameter in this case. So, but this will be the fallback value. So functions return, in this case now, we are explicitly returning a number. Once you provide this, after the parentheses, you provide colon and the data type, that will be the return data type. Here we are doing it explicitly, but you can You can also say that a function is returning void. In this case, it is not going to return anything. So let's go. These are return types. A function can return any data type, all right? But we can also say that this function returns void. It means that it is not going to return anything. And in this case, you can see that we are having an error already. If you say that a function returns void, all right, what you're saying is that it doesn't return anything. So if I take this thing out now, everything is fine. And you can see now that this would not work anymore. The code will not work anymore. So when you have a function that does something like console.log, all right, the return type is void. It's not returning anything. So for me, I think I prefer to use all these return types because it helps me in my function implementation. Because in case I said, oh, I don't want this function to return anything, and mistakenly I return something, TypeScript would flag it as an error for me. Okay, so it means that the void means it is returning nothing. It will not return nothing. Okay, so never means we can also have never. Never means it is never going to return anything. So in cases where your function throws errors, the return type is never. So if I go on now, even if I don't look at it, even if I don't, if I do this and come over and say add, all right. If I take, you can see the signature here. All right. It's returning nothing. But if I try to now say choose uh, show new show new error. Okay. The return type. Look at the return type. Okay, so okay, it's still void, but you can explicitly say this does not it never returns. So we are saying that this function never returns. It will never return anything. So in case you have maybe you have a program that has a while loop and throws an error, the data, whatever they are returning is never. Do you understand? So if I go on now to say it returns never and I say console.log, let's see if it works. You can see it's flagging as an error. It says a function returning never cannot have a reachable endpoint. Do you understand? So these are the different data types that can be returned. Never means it is never returning anything. So throws error, a while loop. When you have implementations like while loop, while true, all right, do this. You can see this is never going to return. All right. So function type definition. So you can also, just like you can create a function and give it you can declare a function and give it a function data type, a function type. So now um, let's say I say this is a variable, and this variable, the data type, sorry, it's not like this, and colon, and then I have an arrow function like this. What does it return? It returns a string. So this is a signature. This is a data type now. It's a data type. So in this case, we have this function, all right? If I now go on to say add and does this, and okay, if I say add is equal to this, I must return a string. If not, it will not work. If I go on to return a number, there'll be an error because the signature, this is the data type. Now, you can use functions as data types. So this is the data type of this add. And in this case, now look at, I'm returning something, I'm returning whatever implementation I give to this guy and this add method now does not correspond with the type of it. It says number is not assignable to a string. So if I want to use this, that means I will have to change this to number and everything will be fine. And I can also say, okay, that this function, this add variable can take a as number, all right? And then So this can also be, what am I doing here? What am I doing here? Why is it giving us this error? Number is unable to, uh, number is unable to type. A is a number. What am I actually doing here? I think I'm making some mistakes here. Okay. Oh, sorry. So this has to be something like A, yes, sorry. Then I can now, sorry. Okay, so you see the reason why TypeScript is very good. I made some mistakes now. TypeScript have helped me. So this is a function type. You can have any signature that you like, and then any assignment to this variable must have that data type, must have that signature. All right, so in this case now, we have this R that takes in the type of it is a function. It takes in two parameters and return a number. So here we are taking two parameters and returning a number. Why does this matter? It is used in callbacks, APIs, and event handlers. So whatever I'm saying here, if it sounds advanced, it's okay with regular practice in TypeScript. These things are going to make sense. Callback functions, you know what callback functions are. You can also make your callback functions have a type. Now, in this case, we have a callback function, and we are saying this is the type of it. We cannot give it, I don't know how much you might understand about callback function, but if you don't understand callback functions, no problem. Just follow along. So let's assume now I am writing a function. Okay, so now I have declared, okay, so let's say I have a function, okay, I have a function add, and this add takes in a callback function, and I am saying that this callback function, any function that you're going to pass to this add as a callback function must have this signature, must have this type. It must return a number. Do you understand? Then I cannot go and say return callback. So if if I call this number now, this callback function, and of course it's expecting a callback function. I have to pass in a function. Let's say I'm passing an arrow function now that returns 7. Everything is perfect. It doesn't complain. But if I go on and say, okay, I'm passing a function that takes a parameter A, all right, and returns A, is a problem because it does not match with the signature. Look at it. It says argument of type of this is not assignable to argument of type of this. So you can see now that TypeScript is helping me to validate inputs and my callback function. So if I want this thing to work now, it's either I change this thing back to what I had before, or I come back here. If that's what I really want, I come back here and say A is of type number. But then I will have to pass in this A here. Sorry. Uh-huh. Okay, so I have to pass in this and everything will be fine. But if I go on and say that A is a string, it will violate the whole thing and there will be a problem. Look at it, it's already complaining. So this helps us. Okay, if you understand what I'm doing, fine. If you don't understand, don't bother yourself. All right, this is somehow advanced. All right, so there's something we call function overload. I don't even think I should even mention this, but just understand there's something we call function overload. All right, you see it in Java, you see it in C++, you see it in C Sharp. Okay, but I just want to mention it to you. Look at it, it's advanced. So I wouldn't want to mention it to you. It will cause confusion here. But just understand there's something we call method overloading in TypeScript. Okay, it is used in APIs, libraries, and formatting utilities. So this is, let me not go into details. Just know that there's something called function overload. And then if you want me to explain, you can chat me up privately, DM me, whether it's on our community, whether it's on WhatsApp, privately, anyone at all. Okay, if you really if you know that you can understand, if I explain this to you, you can understand it, that will be fine. I will do that. So type inference in functions, the return inference, TypeScript based on your code, TypeScript understands what you're returning. In this case, x is a number, x times s is actually a number. So TypeScript will infer that this function is returning a number. You have seen it before. There's something we call contextual typing based on the context. In this case now, all right, we are mapping n, all right. See, when you're doing this thing, TypeScript, okay, let me even show you practical here. So now let's assume we have an array. So let's say let's array equal to, we have a number array, and then we are trying to map through it. When I say array.map, okay, so I'm mapping n to this. I say n multiplied by 2. So look at it. If I take my mouse over this n, you can see that TypeScript has inferred that it is a number. This is what we call contextual inference. Because why? TypeScript knows that this array contains numbers. So there's no way this n will not be a number. There's no way, because TypeScript knows that this is a number. This array contains numbers. So this is contextual inference. So TypeScript infer n is a number automatically because the array that we are mapping contains numbers. So when you do something like windows.add event listener and your click event, or in your click event, you're saying event.client s, TypeScript would know that it is a mouse event. All right, it is only mouse events that have client x. All right. So why does it matter? You don't manually type everything. You don't manually type, you don't manually type everything. TypeScript understand based on the context. All right. So common mistakes: over typing everything. When possible, you can allow TypeScript to infer. Take advantage of TypeScript inference. So in this case now, since we are returning a plus b, TypeScript will infer that it's a number. So there is no need to do this, to add the return type. But for me, I use this because if I'm writing a long function, so it's like a check for me, so that I don't accidentally return something else that I didn't intend to. So using any function, don't use any. Make sure you're using the right type, or you use unknown, and also check for the type. Ignoring optional params. When you have in your code, all right, when you have your function, when you have optional parameters, make sure that you write your code in order to check for the whenever the parameter is missing. Okay, so these are practical tasks I want you to do. Write a calculation function, add, subtract, multiply, divide, and make sure that they are all strongly typed. Both the types for the parameters, both the types of the return type, make sure they are strongly typed. Create a login function. This is the signature. It takes email, it takes password. So create a function, write a function implementation so that it processes whatever you're processing and make sure it returns a Boolean value to show that whether it's true or false. You can also create this function. It takes amount, currency, and then it should return a string. So it means that this function is creating a transaction. So it's going to say, it's going to return a string, whatever implementation you would want to do. Okay, then callback functions too. Write a function, implement this function, and also call it using a callback function that actually satisfies this signature. Okay, array mapping. Try and also do this yourself. I think you have gotten enough information to do this, but if you cannot do any of this, please reach out to me. Okay, so thank you very much, and I'll see you in the next class.